Today we dove a little deeper into the first section of the prerequisite chapter. We looked at some set builder notation, that's here at the beginning. We talked about this vertical line and how this vertical line right there, all that is doing is telling you what is a part of X. So that means, or it reads, X consists of ... like whatever they type there. So on this particular problem, it says counting number, or another word for counting is natural, which that set starts with the number 1. They tell us in this that X is smaller than 6, so that leaves the number 1, 2, 3, 4, and 5. All right. The next part is a little weird. People struggle with the symbols here. So we have first an intersection symbol, and then at the bottom you see we have a union symbol. So anytime you see an intersection symbol, all it is asking you to do, see they use the word and here, another word is both. What numbers are in both sets? That's all it means. No calculations needed. It is just asking you to skim through the first set, look at the second set, and write down what falls in both. So I see an 8 in both, and I see a 10. You're supposed to use those curly braces there. It's not a big deal, but there you go. Sometimes there's nothing in common. There's not a number that falls in both, like example 2. So you can say none, or you can be fancy and write the circle with a line through it, empty set. No, my little note here, if you want to add this, you don't have to write it. No numbers fall in both. All right. The U stands for union, and another word for that is or. Another way to think of it, kind of, is combine. I want to combine both of these sets. Put everything into one set. Just don't write anything twice. Write every number and put in one set. So this means, or at least the way I do it, is I copy the first set as is, and then I write down any numbers that I haven't written down yet. So I see a 6 and a 12. Now, if that stresses you out because they're out of order, then you can put them in order if you want, but it does not matter to me. All right, moving on. The next 2 problems are just practice off of Friday. So we're just sorting those numbers into all the corresponding sets. Could be more than one set for a number. All of the numbers that we're dealing with, I didn't have real numbers on Friday, but all the numbers we're dealing with are real numbers. We're not dealing with imaginary numbers yet. So if you need to make that note, that's actually the easiest question. All numbers in these sets are real. One way to distinguish between real and imaginary is if you can graph a number on a number line then it is real. Now that's not the definition, but it's one way to think about it. So for real numbers, you can just copy every number I typed. They're all real. And for the rest, maybe hit pause and try and do it yourself. See if you can do it without me. And I will move right into it. So the number -7, it is an integer because it's negatives. The ones above it have no negatives. And it is also rational because I can write it as a fraction. I can put a 1 underneath it. -3/4, it is a fraction, but no fractions in the sets above that. And remember also, any of these numbers, or all of these numbers, are either rational or irrational. They can't be both. 0 is a whole number and an integer and rational. The difference between whole and natural, I said it earlier. Natural, another word for it is counting, and it's what you would naturally start counting to 10 with. So if I say count to 10, you're probably going to start with the number 1 and not 0. So 0 isn't included in natural numbers. 0.6 is a rational number because you can write it, 0.6 repeating, as a fraction. It's 2/3. Also, that decimal has a pattern, so it's rational. Square root of 5, if I type that into the calculator, I get a never-ending decimal. That means it's irrational. It never ends, and it has no pattern. It is irrational. Pi, same story. Pi never ends, no pattern, it's irrational. 7.3 does have an ending point, so it is rational. Square root of 81 is a trick. Square root of 81 is 9, right? So it's all of these but irrational. All right, hope that made sense. We're moving on. So for this one, I'm going to hit pause on my recording. I'm going to do it, and it's going to magically appear like in just a second. So maybe you guys hit pause right now. See if you can do it without me. So here we go. It's going to appear in just a second. All right, there it is. Hope you got them all right. And we'll practice it more in class on Tuesday. Now there's a little bit more here. On the back we did a little bit of algebra practice, but I think you're going to think it's pretty easy. So on these it says evaluate. That means you plug in the value that I give you. So if we say x is 5, you just simply plug in 5. And that's what you do on all of these. It doesn't say solve because it's not an equation. If we had an equation, then you could solve it. We end up with 38. On this one, plug in 6. And we end up with 66. Maybe pause it, see if you can do number 8 without me. Plug in 9. Careful with your order of operations. Got to do inside the parentheses first. And you got to multiply before you subtract. So that's going to be 18 minus 16. And we end up with 21. All right, that was it today. See y'all later. Bye.